Hello, everyone. My name is Greg Soden, Industry Manager of Mobility for the Americas with Balluff. We're here today to talk about operational excellence as it applies to the weld shop within the automotive industry. So, what is operational excellence? It's a philosophy that embraces leadership and problem solving as key elements to continuous improvement. It's not just a set of activities to be performed, but rather a mindset that embraces principles and tools to create a sustainable improvement within your organization. It's achieved when every member of your organization can see the flow of value to your customer. But it's not just about reducing cost or increasing productivity in your workplace, but to create a workplace culture that allow you to produce valuable products to your customers and achieve long-term sustainable growth. It's about applying the right tools and to the right processes within your manufacturing industry. It allows you to create a workplace culture where your employees are empowered and motivated. Continuous improvement, also known as Kaizen. Kaizen is generated by the Japanese words Kai, meaning improvement, and Zen, meaning good. And this is a mechanism to achieve quality, productivity, safety, and a positive workplace culture. And there are 6 elements to achieve Kaizen. The first is to identify the problem, analyze that problem, measure that problem, develop a solution, implement that solution, and we measure the result of that problem. So we see the delta between the problem to when the solution was implemented. And then we standardize on that solution for similar processes within your facility. We then move and repeat that process to the next problems that you're targeting. What is OEE? OEE is known as Overall Equipment Effectiveness. It's the standard of measuring manufacturing productivity. We're monitoring quality, performance, and uptime. If we achieve 100% OEE, that means that we're only manufacturing good parts and we're operating at maximum productivity and we're experiencing zero downtime. So it's a powerful metric so that we can identify what our losses are. We're able to benchmark what our progress is, and it helps us in improving our productivity of our manufacturing equipment. So finding operational cost reduction opportunities. So how can we help you in achieving that? Um, of course, companies like yours, you look towards reducing your item costs. Maybe that's through discounted pricing. Maybe it's through rebates or other specialized services that a vendor like Balluff can provide. But there are more powerful cost optimization strategies, and that's what we would like to share with you today. So if we look at this puzzle, each piece of this puzzle represents an element for us to drive out operating cost. So for example, control item consumption. If you're having a high consumption rate of a particular part number, we need to analyze why. Why are we having a high consumption rate of that part? You may also look at the use of reconditioning or having parts repaired. That's another mechanism of driving out cost. It's important that we pick the right fit and right function. So, for example, if you're implementing a standard sensor in a MIG weld cell, that is definitely not the right fit and function, and therefore you will have higher cost. Reducing waste. Our goal is to work with you to find ways to achieve zero waste. Commonize inventory. So by standardizing on particular part numbers, by standardizing on a standard vendor, are ways of reducing your asset carrying costs. looking at ways to reduce obsolete inventory. Training. Are your people in maintenance optimized and getting the best value out of the technology that you've invested in? How do we reduce crib trip time? So reducing the time it takes for your maintenance team in getting to the tool crib to resolve the problems at hand. Reducing cost of purchasing. Of course, the first thing that comes to mind is the unit cost. But if we also look at what the true cost of purchasing is, if we're able to control consumption, if we're able to ensure we're putting right fit and function, if we're reducing waste, commonizing inventory, reducing obsolescence, these are all ways that we're driving out cost of purchasing. And finally, eliminate stockouts. So if we're commonizing inventory, then we're optimizing our inventory levels, which would mean that we're driving out the probability of having stockouts. So how can we help you with that? There are 10 elements that we just looked at. If we try and do all 10 of those, it's highly unlikely that we'll be successful. So I would encourage you to look at what are your top one or two specific challenges. It may be having one, maybe having one problem in your control item consumption, or maybe looking at commonizing inventory. Um, if we pick one or two elements, then we have a high probability of us together being successful in driving out operating costs and a successful outcome. What are some of the root cause misconceptions of sensor and cable failures? One of the misconception is that we allow the machine builder to pick what types of sensors are used and their mounting techniques. And if we looked at the weld industry, there are different processes and there may be different machine builders that excel in different parts of your manufacturing process. And each of those machine builders may have preferred suppliers for their capital equipment, but they may not follow the strategy that you're trying to achieve in driving out operating costs, such as commonize inventory. So, and picking the right fit and right function type strategies. Bypassing a failed sensor in order to keep production running. By doing this, you risk the fate of having escapes of a failed product leaking into your good production components, thereby contaminating batches, which can lead to astronomical costs or operating costs that we'll investigate in a minute. Some companies implement the strategy of putting in many vending machines to make it easier to access spare parts. And the strategy is replace the sensors often to reduce downtime. So if we think of that as we're increasing planned downtime to reduce unplanned downtime, the net result is that we're still increasing downtime. So we need to pay attention to some of those other 10 elements that we looked at earlier to pick the best solution to drive out operating costs. And finally, the sensors are going to fail anyway, so let's just buy the cheapest one possible. So again, using the welding as an example, if we applied a standard sensor into a MIG weld cell, we can guarantee that that device is going to fail at a very high failure rate compared to a sensor that's designed to be used in a MIG weld cell environment. So with that in mind, what is the real cost of premature asset failure? Of course, we know it's the cost of the component, but there's more to the real cost. What are those costs? Well, of course, we're going to have lost production time. We're going to experience unplanned maintenance costs. We'll have an increase in planned maintenance costs. Unplanned machine downtime and overtime costs will increase. Your indirect inventory costs will increase. You will have part quality issues. You will have unbudgeted expenses, increased manpower costs, higher scrap level costs, sorting costs, rework costs, expedited freight costs, outsourcing costs, and poor asset utilization. These are all real costs that your company experiences when you have high failure rates. These costs will be reflected in your plant's P&L, and if they're significant enough, they could be reflected in your annual report back to your investors. So it's important that we pay attention to picking the right technology for the right process. So when we work with you to implement um, uh, a solution, what we want to do is work with you to identify what the cost of the problem is. So with that, we need three elements. And one is we need to understand what is the frequency of failure. Is it once per hour? Is it once a shift, once a week? What is that frequency of failure? Second is we need to understand what is the mean time to repair. So what I mean by that is from the very time the operator identifies that there's a problem until that problem has been resolved and that capital equipment has now recovered to full production. So what is that time in minutes? And finally is what is the cost per minute of downtime? If we understand all three of those elements, then we can affix the cost of that problem. This is the very first step in the continuous improvement program, or Kaizen, that we talked about a number of slides ago. So let's look at an application that a customer had. Here is a Weld fixture. There are 17 small flat pack sensors that are in various locations on this fixture. In this case, there is a failure rate of one of these devices failing once per week, and the mean time to repair is 20 minutes. And the cost per minute is $40 per minute. This means just on this side alone, and this is a trunnion, so this rotates, there's an identical side on the other side. Just this one side alone has an operating cost of $41,600 per year. The expenditure of the sensors to replace them once per week is $3,120 a year. So even if these sensors were replaced free of charge, which sounds like a great deal, it's not such a great deal. It's costing you just on one side over $41,000. So it's not uncommon to have many of these machines in a plant. So your operating costs can exceed into the hundreds of thousands of dollars very, very quickly. So it's important that we're picking the right technologies for the right process. Well, what we need to do together as a team is examine and understand the root cause of the failure. We need to benchmark, so establish what that problem is costing, make practical recommendations for that problem. Together, we need to establish a timeline and a progression chart as to when we will implement that solution and measure it. We need to measure the success, not just implement a solution, so that we can justify that we're on the right path of putting the correct solution for the problem at hand. So our goal really is to achieve a level of trust with you so that Balluff becomes a trusted advisor for you and your team, and we're more than just a component provider. So to help us in achieving this, we have a number of tools at hand. Here's an example. We have a sensor evaluation Dropbox program where we've pre-printed these tickets. And on that ticket, we've identified a cell name, the op station number, and a date. Other information, if your team fills that in, that's great. But those three elements are key. We affix that ticket to the failed device, whether it's a sensor or a cord set, and then it's deposited into this bin. So what is absolutely important is that all of us together, not just us, but your complete team, your complete maintenance team, where everybody understands the process to follow so that they understand that the ticket needs to be completed, it's affixed to the failed device, and then it's placed into the drop box, and then Balif at an agreed frequency with you and your team, we would complete this spreadsheet document where we're identifying the cell name, the date, the op station, and what is the root cause of failure. So we test each and every part, and then we complete this document. Once we understand once this document is completed, we can then sort by cell, by op station, by date, or by failure, and we can identify and isolate where our highest failure rates are. So that concludes our discussion on OpEx. And to get better ideas, not only what we've discussed, we have a new Balif Weld Select brochure that is in our website. You can go to our download section in our website, download this brochure, get other ideas and strategies. And by all means, you're more than welcome to contact me directly. I'm happy to help you, get you linked up with the area sales manager that's in your territory. And thanks again for your time. Stay safe and stay healthy. Thank you.